Hello everyone and welcome to our We Meet at Digital Days. My name is Eleni Stark and I will moderate this presentation. We are very pleased that you took your time to participate in our virtual conference. The topic of this presentation is Sustainable Food Production with Horticulture LEDs. Our speaker is Johann Waldherr, our Business Development Manager. He will hold the presentation and also will answer your questions. Before we start with the presentation itself, I would like to point out that you are going to be muted during the presentation. This means that you cannot ask us questions via microphone during the presentation. Nevertheless, you have the opportunity to ask us all your questions during the presentation at any time via our chat function. You'll find the chat function in the control panel. The presentation itself will be about 30 minutes long. The questions will then be answered in a Q&A session following the presentation. There are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all your questions within this time, we will answer them via email afterwards. If you still have any other questions left, just mail us at exhibition@we-online.com. We will try to answer all your questions promptly. At the end of the presentation, you'll be asked to participate in a feedback survey. We would be very pleased if you take your time to fill out the survey and help us to improve our event. You will receive the link to the presentation in the next few days. The recording will be available at our website shortly. Now we'll hand over to our speaker Johann Waldherr, and I wish you an exciting presentation.
Yeah, thanks for the introduction, Doreen, and also welcome from my side. My name is Johann Waldherr. I'm Business Development Manager here at Würth Elektronik for Horticulture LEDs. Perhaps also a few words to my background. I'm a plant scientist, and I focused especially on how different wavelengths influence different quality parameters of the plant. And today, I prepared the following topic for us. It's about sustainable food production with horticulture LEDs. And I prepared here for us today the following agenda. First, I will focus on challenges of humanity. So why we are doing this and why we are looking for alternative cultivation methods. Then I will give you an overview about a new cultivation method called controlled environmental agriculture. Here I will focus on vertical farming. What is it? What is it about? What are the benefits here? After that, I will give you an overview about why we need horticulture LEDs here and what are the characteristics here and the benefits to use it. What is important to understand here? Optical parameters, biological parameters, and electrical parameters. And in the end, I also will show you what we are doing here in the special field. So why Würth Elektronik, what can you expect in the service of us here? Okay, so let's start. Challenges of humanity. So it is expected that the world population will grow till 2050. We expect around 90 billion people will live till 2050 on our planet. So we have a growing world population. In addition to that, we see the climate change. So we have unpredictable weather conditions. Sometimes it's very, very warm. It's very dry. We have hail or a lot of storms, for example. So we have unpredictable weather conditions. Then additionally, we also lose more and more farmland. And yeah, also the air and water pollution is a big topic. So, and of course, we must save our resources. And all these challenges, so a higher world population in combination with less usable farmland under unpredictable weather condition is not really a good combination. And we have to look for alternative cultivation methods to feed our world. And how can we secure the food supply? One possible solution here is, vertical farming is controlled environmental agriculture. And therefore, we need horticulture LEDs. I will explain in the next slides why we need it and how we have to use horticulture LEDs and what is this cultivation method about. And yeah, horticulture LEDs can contribute to be a part of the solution. Of course, I know it won't be the only solution, but it can contribute to be one part of it. Everybody of us have to think about their own behavior, how we use our food, how we consume our food. So it's also important, buy just this amount of food we really need. This is also a big topic. So as I said, this cultivation method, also horticulture LEDs, can contribute to be one part of the solution. And yeah, what is controlled environmental agriculture? Controlled environmental agriculture, the short form is CEA, is the cultivation of plants under optimal growing conditions. So we control humidity, we control CO2 content, temperature, watering, nutrient content, but of course also artificial light. So this is what you can imagine is controlled environmental agriculture. And here we have two main applications for controlled environmental agriculture. The first one is the indoor farming. It's a completely controlled CEA. Here also vertical farming belongs to it. I will focus on this on the next slide. What is vertical farming? What are the benefits here? And the second big application of CEA are greenhouses. But greenhouses are not a fully controlled environmental agriculture, it's a semi-controlled environmental agriculture, because here we also have the influence of the sunlight. And we can't control completely the sunlight. And what is also important for me here to mention, CEA is a chance. It's not a competitor to traditional farming, but it can, CEA won't replace traditional farming, but it will support traditional farming. This is very important to understand, because we also need new methods, new cultivation methods to feed the growing world population. But therefore, we need both traditional farming and also new methods. So what is vertical farming? Vertical farming you see here in this picture is the cultivation in a multi-layer system. So we cultivate to the top, from the bottom to the top. Vertical farming was made possible by the LED technology. Without LED technology, it won't be possible to cultivate in such an application. Why? Because we are very close with the light to the plant. The heat generation here from the LED to the plant is very low. So that's the reason why we can put the LED very close to the plants. And therefore, or that's the reason why we also can grow to the top. It's not possible with, for example, HPS luminaires, because the heat generation there is too high and we will damage the plant. Yeah, what is vertical farming? Vertical farming, here I wrote it, it's the farm of tomorrow. It is agriculture in the middle of the city and really close to the customer. And as I told you, we use multi-layer cultivation systems. So when we grow to the top, we also can save space. So we need a minimum growing area. Then in such systems, you see it here, the pipes here and here and here. We use hydroponic systems. Hydroponic systems are systems where we have a closed water and a closed nutrient cycle. So we really use this amount of water what the plant needs and this amount of nutrient what the plant needs, and nothing get lost. It's possible to save 95% of the water compared to the same area in traditional farming. And it's possible to save 65% of the nutrients compared to the same area on a traditional farming. And of course, when we produce our food directly in the city, we have no transportation of the food. We can harvest on demand, which means the plants are really ripe and the nutrient content is much higher and the taste is normally also better. And when we have no long transportation of the food, we also save CO2 here. And when we optimize the grow conditions, for example, via artificial intelligence or with an app control, it is possible to guarantee the same quality everywhere in the world of the products, of the plants. So we can grow everywhere in the world, also in challenging places, like in the desert or also in the Arctic, for example. And this is something what is made possible through the complete control of all parameters like temperature, humidity, CO2, and many more. And this is vertical farming. And therefore, we need artificial light. So here it's a summary of, I showed you a few challenges of today, and here are solutions which we can achieve with the vertical farming system where we use horticulture LEDs. So vertical farming is one part, as I told you before, which has the potential to contribute and to help against these challenges. So for example, we have in such a vertical farm a higher harvest efficiency. So more yield because of we grow to the top, and we can cultivate also year round, so we are better independent. It is also resource gentle, like we save water, we save nutrients. And yeah, we also can reduce yield losses. As I said, we are weather independent. And of course, when we grow to the top, we compensate the loss of farmland too. And when there's no far transportation of the products, we also can save CO2 here, and we also can reduce the food waste during storage, for example, or during transport. And yeah, we have no uncontrolled leaching of the nutrients, for example, like in the traditional farming. So you see, there's a lot of potential in such a system. And for such a system, yeah, we need artificial light. Here, it's one slide about what are influencing factors in a vertical farm. Influencing factors in a vertical farm are nutrients, is the watering system, the humidity, the temperature, the CO2, and many other parameters. But one of the most important is light. Without light, the plant will grow. And without light, it is, the plant won't grow and nothing will happen in your farm. And therefore, I think you got a first overview about what is the potential and why we are doing this to support the system. On the next slide, I will focus on how it will work to use the right LED combination and how horticulture LEDs will work to grow plants. And yeah, therefore, I will focus first on the biological basics. After that, I will show you the optical basics and then the electrical basics, that you will understand why this system is so, has so a big potential. So on this slide, I will focus on the biological basics. Here on the left side in this picture, you see different absorption pigments of the plant, where the plant recognizes light and can absorb light. And one very important region is from 400 nanometer, this is blue light here, till 700 nanometer, this is red light. It's the so-called PAR region, the photosynthetic active radiation. This region, the plant uses this light here for the photosynthesis. And you see, we have one peak at 450 nanometers. This is a very important wavelength. This is a blue LED. We have a peak here at 660 nanometer. Also, this is a very important wavelength for plant cultivation. And we have a peak here at 730 nanometer. This is outside of this PAR region, but this is also a very special and important wavelength for plant cultivation. This wavelength is in the so-called plant biological active radiation region, the PBR-AR region. This is the region from 280 to 800 nanometer. This is the region where plant can recognize light and use different wavelengths for different developmental stages during the cultivation. Important for you to understand is blue light and red light, the 450 to 660 nanometer, are very important because the plant can use the photons here very, very good for photosynthesis. And also outside of this region, so for example, UVA radiation or far-red radiation, for example, the 730 nanometer, and the plant also can recognize. And with this light, we can control other quality parameters of the plant. For example, the 730 nanometer can control, in combination with the 660, the flowering time. For example, for the grower, it's interesting to bring their products on the market on Mother's Day or Valentine's Day. With these two special wavelengths, you can control the flowering time. With the UVA radiation, you can increase the secondary plant metabolites, for example. This is also a quality parameter. Secondary plant metabolites for us are, for example, vitamins. And when you know what is the goal of the garden or what is your goal, what is your quality parameter, could also be more biomass, for example. When you know this, you can create a light recipe which are focused on this quality parameters and which increase this quality parameter. And yeah, on the next slide, here you see the optical basics. So in the slide before, I told you the plant can recognize different wavelengths, can absorb the energy of this different wavelengths. And the horticulture LEDs now emit exactly there the photons where the plant can absorb it. So we have here, for example, the special horticulture wavelengths 450 nanometer. Here we have the peak exactly there where also the plant absorption has the peak. So this is why LED technology is so efficient, because we really give the plant the light what they need. And yeah, we developed our LEDs for customized light solutions. So we can create with our LEDs, with the different wavelengths, different light recipes exactly on the target quality parameter. For all horticulture lighting application. Here we also have LED at 660 nanometer, or LED with a peak at 730 nanometer. So important to understand is, with the LED technology, we can exactly emit the photons, the light, in the right region where the plant can absorb these photons and where the plant can use these photons for photosynthesis or for the development of other quality parameters, like secondary plant metabolites, like increasing the biomass, target flowering, better rooting, for example. This is important to understand. And this is also important to understand why vertical farming or the LED technology by itself has this big potential. Yeah, and here you see what I told you. We offer here 3 special wavelengths: the 450 nanometer, the 630, and the 730 nanometers. But as I told you also, sometimes you need other wavelengths to increase your target quality parameters. And therefore, we have UVE, we have other reds, yellow, green, blue LEDs, and also white LEDs. You will find this more information on this on our webpage. There you can find the whole portfolio here. So these are high power products, mostly used in greenhouses. And on the next slide, we have the same LEDs also in mid power. And these mid power LEDs are very often used in vertical farms, for example, or a mix of high power and mid power. But I will show you later what we can do from Würth Elektronik side and how we will help you here to find the right LED combination. Yeah, here that you can see also a few examples and how light will influence the plant growing. You see here on the left side a full spectrum LED, and you see in the middle a combination of the blue and the red LEDs. Then you have this typical purple light you also can see in the background here. Here on the right picture you see this was one experiment here, how light will influence the plant development. So everything was the same here, like same substrate, same seed, same watering, same temperature. Everything was the same. Only the light condition were different. And you see different light conditions leads to very to really different plant phenotypes. Yeah, and this is also a very big benefit of the LEDs, that you can adjust the spectrum. And you also can use dynamic lighting. For example, different cultivation stages, like the plant need different light ratios between blue and red during the seedling stage. Then in the vegetative phase, where they produce leaves, or also different ratios where they produce flowers or fruits. And this is also possible with the LED technology to set up dynamic lighting systems. Yeah, and one last point here, what you also have to understand and to know when you are planning something in horticulture lighting. 3 electrical basics here. So 3 parameters which are very important to understand in plant lighting. The first one is the PPF. It's the photosynthetic photon flux. The photosynthetic photon flux you see here on the left side. It's the amount of photons, which really comes out of my LED. So it's the amount of all photons which are emitted from the LED in all directions. And the unit here is micromole per second. The second important value is, it's the most important parameter for growers, for gardeners, for the user of a vertical farm, is the PPFD value. The PPFD value is the photosynthetic photon flux density. This is the amount of all photons which come out of my LED, of my luminaire, and which hit 1 square meter where my plants are, so which hit the target illuminated area. So these are the parameter. You can say this parameter shows how many photons the plant really can use. And this value, or this parameter, is very dependent on the distance between luminaire and plants. So the closer you are to the plant with your LEDs, the higher will be the PPFD value. The unit here is micromole per square meter in a second. You also can compare these two parameters with human light. For example, the ppf value is comparable with lumen. So for us human, we have the parameter lumen. For the plant, we have the parameter ppf. And the ppfd value is comparable with the lux value. So just to understand for you how you can, compare it. And the last one is the efficacy, the photon efficacy. Also very important. This is, refers to how efficient your lighting system is at converting electrical energy into photons. And the unit here is micromole per joule. Okay, and here a summary. What are the benefits of horticulture LEDs in a vertical farm, and what are the benefits of a vertical farm in combination with horticulture LEDs? Of course, you have biological advantages. You can cultivate year-round, you are weather independent, you can increase your target plant quality parameter, and you have a higher harvest efficiency, which leads to more yield. Then you also have these electrical benefits, because LED technology have a high lifetime compared to other light sources, a much higher efficacy than other light sources. Then you have lower maintenance cost and a lower operating cost, which leads to less energy costs. And additionally, you have these environmental benefits, like you are resource gentle, you save space, and you can harvest on demand. So the combination of more yield with less energy cost is, it's a good combination. You can get a fast return of your invest, and in the end, the grower has more benefit and more profit. And the green revolution already started. Vertical farming grows 24% every year, and also caused by Corona. And the last year, this market increased faster than everybody expected it. And it's a big market with a big potential. And let's see what happened in the next years here in this technology. But I hope you understand the benefits of this technology and why we are doing this. And now, what is the special what we are doing here at Würth Elektronik? So, of course, our LEDs have a very high ppf output, and very important is we deliver really the whole necessary spectrum here for all horticulture lighting application, vertical farming, greenhouse, but also for example, home grow boxes. And we help you to find really the right LED combination. If perhaps you need mid power or high power, full color or monocolor, doesn't matter, we will help you. And we define with you the correct spectrum for your quality parameter of the plant. And how we do this is, of course, we also have our own plant scientists in our team. Like me, I'm a plant scientist. We have cooperations with universities, and we do our own biological tests. And the knowledge we generate here, we use to create with you light recipes. Here on this slide, we also have 3 experiments. One experiment with the basil. Here it was possible with LED technology, with dynamic lighting, to cultivate basil faster. So the grower was able to have 2 more cultivation cycle per year. So 2 more cultivation cycle per year is a lot of more yield. Here in the middle, we had an experiment with spinach. Here it was possible to increase the nutrient content, the flavonols as a secondary plant metabolite, after 8 days. So we doubled after 8 days these special secondary plant metabolite compared to natural sunlight. And here on the right side, we had an experiment in a greenhouse with tomatoes. Here we were able to induce more flowers and to induce it in the winter. So also this means cultivation the whole year. And we do actively this research, and we use the results and share also these results with you to help you and to support you in finding the right LED combination. And at last, we also have a few special tools here, what you can use. It's the lighting development kit. Here, everything is included, like a power board and a Horticulture LED panel, also other LED panels. It's completely ready to use for you and to develop your own lighting system. You can control 4 different channels with 4 different LEDs via app. And yeah, you can do your own plant research with this lighting kit, for example. You also have a tool, it's called the Horticulator. It's integrated in the Red Expert, and there you also can create your light recipes. You can see immediately when you, for example, choose 10 red LEDs, 5 blue LEDs, what is your spectrum here. So you can find all necessary values like PPF, PPFD, PPE, everything what you need. And yeah, of course, we also have application notes where you can find a lot more information on general horticulture lighting, on what are the benefits here in horticulture applications like vertical farming. And also the last one is why, for example, use far red, how you can create own light recipes. And you find this all on our webpage. It's www. There's the normal Würth Elektronik webpage with /letitgrow. Yeah, and to summarize, I hope you got a first impression about this topic, why the LED technology is so beneficial here, and why we are thinking about, or why we are doing this, or why we are pushing this field vertical farming more and more. And I think you see the potential of this technology. Of course, we are here in the beginning of this technology, and we have to learn a lot more, but the potential is there. And I think, yeah, we need new solutions, and this can be a part of one solution, as I said in the beginning. And yeah, we are faced with more and more challenges like climate change, growing world population, the loss of farmland, and we need a better use of the resources. And to solve these challenges, Würth Elektronik is actively accelerating the green revolution by supporting the development of such a farm and to ensure with such a farm the food production in the future. Yeah, I hope you got a first impression. I'm looking forward to your questions, and thanks for your attention.
Thank you very much, Johann, for this interesting presentation. Like you already said, we would like to turn our attention now to the questions that have already come in. And I will just check the first one. So, is the vertical farm profitable? That is one question.
Yeah, thanks for this question. This is one of the first questions always in such a webinar. Yeah, it is rentable. It always is important where, for example, the vertical farm is set up in cities or in countries where you import very much food, where you have no own cultivation. For example, yeah, we say, for example, in Dubai, there we have very special conditions, climate conditions. They import a lot of food. There, it will be rentable. to produce their own food in such a system. And it always also depends on which plants you will grow there. At the moment, it's not rentable to produce rice or potatoes, for example, in such a system. But it's rentable to produce lettuce or different herbs. So as I told, we are in the beginning here. It depends always where is the farm and what are you producing in this farm. And then let's see what the future will bring us. I'm pretty sure that also in the future, other plants like tomatoes or strawberries are also rentable. Everything will work, but yeah, not everything is rentable at the moment.
Thank you very much for this answer. So let's skip to the next question. Do plants need different light conditions in the different stages?
Yeah, also thanks for this question. Exactly. So, for example, seedlings need a different light condition, for example, also light intensity and light quality compared to older plants, which are, for example, it's called the vegetative phase. Vegetative phase is when the plant produces leaves, for example. And we also have a third phase, it's the generative phase, where the plant develop flowers or fruits, for example. In all these three stages, we also, the plant need different light conditions and light intensity. And therefore, one big benefit is this dynamic lighting, what we can do with the LED technology. So for example, we control all the blue LEDs in one channel. We control all the red LEDs in one channel, just an example. Then we can change the ratio between these two wavelengths during the cultivation cycle and can optimize the cultivation cycle. And yeah, I hope this answer was enough. So yes, the plant need different light quality and also light intensity, but this is one big benefit of the LED technology, that we can optimize this.
Thank you very much for that. The next question, can you remotely monitor and control the LEDs?
I think I'm not sure if I get the question. Can you remotely? In general, yeah, you can control all the LEDs, and this is. I'm not sure if I get the question, if I'm honest. So perhaps you can write a little bit more exactly what you mean here.
If not, we can go
Then
on to the question you asked.
I also will exactly, yeah.
We
And
will
I
go.
will also answer this then later.
Okay, great. So a next question that we have is, how do I find the right spectrum, and how do I know which LEDs should I use and how much should I use, or how many should I use?
Yeah, this is what we are doing at the moment. We are working together with universities. We are also doing our own light experiments in Waldenburg, for example. And here we focus on these light recipes. We set in the first stage, we set a quality parameter, as I told you. For example, a quality parameter could be better routing. And then we define different spectra where we think, okay, this is possible to increase the routing. And then, yeah, we see which spectrum will work the best. And with this knowledge, and we can also generate the light recipes here. and we can say, okay, in your luminaire, we need the ratio 20% blue, 75% hyper red 660 nanometer, and 5% far red 730 nanometer, for example. Then the next stage is, okay, we need, for example, the illuminated area. How big is the area where your plants are? What is the distance between luminaire and plants? And then we can calculate for you the amount of LEDs you need for this area. And we also can recommend you, okay, how many luminaires, for example, do you need with this special amount of LEDs?
Okay, thank you very much for your answer. So the next question is, more about social aspects, I think. Is a vertical farm not like unnatural?
Um, it depends. So, of course, a vertical farm, it's artificial. So we use artificial light, we control everything. But in a vertical farm, we use we use the natural processes of the plant. We control the natural processes of a plant. So we don't use any GMO, genetic modified plants, or anything else. We use plants which we can also cultivate outside, and we use the natural processes there. You also can think about, is a greenhouse, for example, natural? Also there, we produce, we optimize plant growing. We use there the sunlight, of course, yeah. And it's perhaps more natural than a vertical farm, but this is something what everybody have to think by their own, if it's natural for him or not. Of course, it's something artificial, but we use the natural processes in the plant development.
Thanks for your opinion here. So I will check. We have a lot of questions coming in. So the next one, maybe, do you have or plan to make it possible to upload, store, and use plant lighting recipes for different plants?
Mm-hmm. Yeah, this is a good point. So this is the plan in the future, to have something like a database for different plants, because yeah, you are right. Also, different plants react different to different light conditions. This is so very special topic. There are few light recipes which will work for all plants more or less. For the one plants better than for the other plants, but they will work. But to optimize this, it's necessary to have a database where you have light recipes, for example, for tomatoes, where you want to have more fruits, or for lettuce, where you want to have more biomass. This is necessary in the future. And yeah, we are working on such things. At the moment, it is like, as I said, we already have light recipes, and we talk with the customer, we share this knowledge, but it's not published on our webpage at the moment. But this light recipes we already have, and we will use and share with you when you get in contact with us.
Thanks also for this. I think we have still time for one more questions, because we're already running out of time, so we can get one more question answered. So our last question for today, is the light from Horticulture LEDs safe for human eyes? Are there any restrictions in this regard?
It's safe. So we, of course, it's like always, it's not really good if you look directly into the LED, but you also can't look directly in any light source or in any LED. But you have the same restrictions like for human lighting. So for the blue LEDs, we have the biological safety tests, which we fulfill, and of course, all the restrictions what we have here in human lighting, we also have in plant lighting. So the LEDs have to fulfill all these requirements, which you also have to fulfill in human lighting. So there's nothing different.
Thank you very much, Johann. We still have a few questions left. Unfortunately, as I said already, we are running out of time, but we will answer all your questions. So no worries, you will get answer for all your questions. We will just answer them via email after the webinar. Now I would already like to draw your attention to our next presentation, where the topic will be disinfection with UVC LEDs, which will start already in a few minutes at 3 p.m. Yeah, and I would like to thank you once again, Johann, for this interesting presentation, and to our attendees also for listening and for having us. And yeah, maybe we can see each other in the next presentation again. I all wish you a nice afternoon, and yeah, bye-bye.
Yep. Also from my side, thanks for the attention. And if there are any questions, feel free to get in contact with us, with me. And looking forward to help you here in this special topic. And yeah, thanks for your attention and have a good week. Bye-bye.
Thank you, Johann. Bye.